Okay, Regents Worksheet 2.2. Really quick little help video here to kind of get you going on this one. I had made this video last night, but my cell phone cut out. Anyways, let's get going. This first one here gives you some different data on different planets. Oh, great. Racing wonderfully this morning. Oh, it's cold down here. Alright, so anyway, remember, the main equation is Fg equals G M1 M2 over R squared, where we have two objects with some mass, some distance between their centers, which is R, M1, M2, and we're determining the magnitude of the mutual gravitational attraction. Right? Fg and Fg, they each experience that amount of force due to their masses and their distance between them. So number one here, you just, part A and B are simply plugging and chugging into this equation with really big numbers in your calculator. For number one, it's between the Earth and the Moon. So mass of the Earth, mass of the Moon, and distance between them. That number there is the distance between them, okay? I've got the focus lock on here, so it's not going to focus when I move it, but it's that distance from the Earth. And then part B, determine the mass in the sun. That's a little bit different because you're going to be solving for M1 or M2, depending on which way you want to set it up. So I would probably make the Earth M1, the sun M2. We know the force of attraction between the Earth and the sun, which is that number there, that 3.5 times 10 to the 22nd. We're going to plug them in and solve for M2, okay? Number two, part C, I want you to try to think about that one, and we'll talk about that one in the solutions or whatever there. So part number two says two objects, mass M and M, are attracted to one another by a gravitational force of 100 newtons. When separated by a distance of R. Sketch the arrows. Okay, basically I've done that for you here. Determine what the force between the two masses will be if the distance between them is halved. All right, so we have kind of the way I like to do it is G big M little m over R squared. If I have R, that means it becomes G big M little m times R over 2 squared. So if you're having the distance, you're putting them closer together. That's going to make the force stronger. And because it's squared, it's going to be 4 times stronger. So I don't really go through the whole proof. I just think, okay, farther away is weaker, closer together stronger, and then the effect is squared because it's squared in the equation, the radius. So if you're having the radius, you're cutting in half, it's going to be 4 times stronger. And then see if you can figure out part C and D. All right? On the back here, gravitational force of attraction between two objects would be increased by, you can figure that out. Number 4, when a satellite is a distance r from the center of the Earth, the force of gravity on the satellite is F. What is the gravitational force in the satellite when its distance from the center of the Earth is 3r? So again, we kind of talked about this before. I'm going to leave that for you. Number 5 is plug and chug in this equation, but they give you 3,000 millimeters as the unit, as the radius. 3,000 millimeters. Hint, milli. There's 1,000 millimeters in 1 meter. Okay, so you have to always convert to meters. Number 6. Okay, so this one is just proportional reasoning. It tells you the weight. Weight is force of gravity. So 100 newtons is the force of gravitational attraction of this object on this object at Earth's surface. So 0.1 Earth radius above Earth's surface. We talked about this in class, but you may not remember. Let me try using this rag to wash this off a little bit, see if it works better. Not really. This whiteboard maybe not the best choice. Or it just might be because it's 40 degrees in my basement right now, in my garage, and maybe that has an effect. All right, so 1 Earth radius above the Earth. If the Earth has a radius RE, if you go another Earth radius above the Earth, all right, you've now doubled your distance to the center of the Earth. All right. What is the order of magnitude of the gravitational force between two 1 kilogram charges that are positioned 1 meter apart? Well, what the heck are charges? Well, we'll talk about that later on. The important thing here is order of magnitude, and I'm going to show you a couple examples of that. Order of magnitude is simply the number, when you write something scientific notation, the number that ends up being on the 10, the exponent on the 10. So let's say we had 6, 5, 3, 2, 1, 1, 1, 1, 1. All right, so that's, all right, 653,000, whatever the number might be. Let's write in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. 6.5 times 10 to the 8th. The order of magnitude is 8. All right, the order of magnitude is 8. It doesn't matter what it is. Okay, so any number. So you could make it, you know, 0.00000021. All right, scientific notation. 1, 2, 4, 5, 6, 7, 8. I did 8 again. 2.1 times 10 to the negative 8th. The order of magnitude is a negative 8. Negative 8. All right, so then it's important that you only make it 1 decimal place, though. Okay, or not 1 decimal place. I'm sorry, 1 digit in front of the decimal point there. Proper scientific notation. All right, that's all the order of magnitude is. All right, it's just a number on the power of 10 when you put a number in scientific notation. So do the calculation, get the answer, and report it. All right, cool, great. Just a little help on that worksheet. Do your best, and then I'll post more detailed, probably just a PDF solution of this. I'm probably not going to do a whole video working through all these. I'll probably just post a PDF and then take questions on it. All right, see you guys later.